Hold on. We need to work on your language, the language of what you were describing right there. So you tried to simplify, okay? My guess is you tried to simplify it. What stumbling block did you run into? You can't. There's nothing to do. What is that?
Addition.
Prime. It is prime. There's no way to factor that. There's no way to factor that. You can't factor it. You can't factor it. Why? 4x squared is always positive. So if that's always positive and 1 is always positive, or 0, right? Is there any way for the denominator to be 0? Okay, the paper, really, Summer? Oh, okay. Is there any way for the denominator to be 0? No. So therefore, what is the domain of this function? Correct. The domain of this function is all real numbers because there is no way to make the denominator equal to 0. There is no way to make the denominator equal to 0. Yes, that can be. No. 1. It's always greater than or equal to 1, right? That's why the domain is all real numbers, because there's no way for it to be equal to 0, because it's always greater than or equal to 1. Because the denominator is always greater than or equal to 1, is there any way for it to be equal to 0?
No.
If something is always greater than 1, is it ever equal to 0?
No.
So therefore, is there anything that makes the denominator 0? No. So therefore, the domain is all real numbers. Number 6 was asked about. 9x plus 8 over x. What's the domain here? X such that x can't be equal to 0. Hey girls, question? Okay, not 0. Correct. Yep. What's up?
The number is anything but 0?
Yes, the domain is anything besides 0. The domain is anything besides 0. That is correct. Is that the same thing as the original? Is this the same as that?
No.
Well, let's check. Let's check. Could I multiply the top and the bottom by -1 if I wanted to? I could if I wanted to. -1 over -1. Have I changed the value of it if I multiply by -1 over -1? Why? Because it's the... Why am I allowed to multiply by -1 over -1? Because it's the same as multiplying by 1. Correct. So if I multiply by -1, what do I get on top? -3 plus x over what? -x plus 4. And what's that equal to? X minus 3 over... Oh, it is the same thing. It is the same thing. So what about b? Let's try b and see what happens. b, 23. It's x plus 3 over 4 plus x. Is that one the same? No, it's definitely not the same. Can you just change it to positive and have it be the same thing? You can also test this by just plugging in a value, right? What value do you want to plug in here? What happens if I plug in 3 into here? What happens when x is equal to 3? That comes out to be 0, right? So 0 over 1, which is 0, right? So if two things are the same, they have to be the same for all values of x. What happens if you plug in 0 right here? X equals 3. What do you get? 6 over 7. That does not equal 0. So which one is not equal? It's b. It's b. And assuming, we can test the rest and see what happens here. Let's try it. See, what is it? -3 minus x over 4 minus x. That negative sign. Distribute. Where should we distribute? Oh, distribute to the top. What do you end up with? -3 plus x over 4 minus x. What does that equal to? Is that the same thing? Yep, that's the same thing. And what's d? d is negative x minus 3 over what? Where do you distribute the negative sign this time? The bottom. Over negative x plus 4. And what's that equal to? 4 minus x. There it is. So is it the same? Yeah. So what's the only one that's different? b. b is the only one that's different. It's already in lowest terms. You're done. There's nothing to do. There's a plus in the numerator. You can't cancel anything. If you made that x plus 7, that would be painful to see. Don't do that. You can't cancel the 3's because of the addition sign. So you're done. You could rewrite it. It's not necessarily considered simpler, but you could rewrite it as 3x over 3 plus 7 over 3, which is x plus 7 over 3. That's another way to write the same thing. Is that necessarily considered to be more simplified? Nah, no. So that's not what I'd be looking for. If I gave you 3x plus 7 over 3 and said simplifies it, it's done. It's already simplified. It's already most simplified. And 4. Let's say I asked you to do this. Okay, let's say I asked you to do 5 over 12 plus 7 over 12. Not 5 over 12 plus 7 over 15. If I asked you to add those fractions, what would you need to do first? In complete sentence form, what would you need to do first? Alex?
First, you would have to get a
Common denominator. You need a common denominator to add fractions. That never changes. To add 2 fractions or more, you need a common denominator. So, which denominator should we aim to build? Anybody want to guess? What denominator should we aim to construct on this fraction? What should we aim to construct? 60. 60. We want to aim for 60. 60 would be called the what common denominator? Close. The greatest doesn't exist because you can always make it bigger, right? 60, 120, 240, 120 million, right? We're looking for the least common denominator. Least common denominator. It's implied, yeah, whole. But we usually don't say whole. So if we did that, we can only multiply by 1 because 1 is the only thing you can multiply by and keep the same value. So what do you multiply 15 by to get 60? 4. And if you multiply 4 on the bottom, you have to multiply 4 on the top. What about 12? What do you have to multiply by 12 by? 5. So what do you multiply on the top? 5. Have we changed anything by multiplying by 1 twice? No. What does this equal? 25 over 60 plus 28 over 60. So what's that going to be? 53 over 60. Nice. So we've added them together. But what was key here? We needed a least common denominator. This is not going to change. This need is not going to change. Sometimes it might be a little easier than other times. So let's take a look at these two right here. What do you notice about these two problems immediately? If I ask you to add these, what do you notice immediately? They already have both common denominators. Does the math change? No. You already have common denominators. So what's this one going to equal? 3y plus x over 5. What about this one? 7 minus 11 over what? Which is negative 4 over 2r squared. Can we simplify that a little bit? Yeah, it's going to be negative 2 over what? R squared. So nothing really changed. We already had a common denominator. But are we always going to have a common denominator on these? No, we're not always going to have them. So you need to make them. What you're going to do is always try to begin with factoring, though. Generally speaking, do things get easier or harder if you have the factored form of something? Easier. So you factor, find a least common denominator. Those are your first 2 steps. You factor and you find a least common denominator. So let's just start with one. Let's start with this one right here. I like this one right here. So on this one, is any factoring needed on this one? No. No factoring is needed. There's no factoring that can be done. But you need to identify the least common denominator. So as a hint, I'll ask you this. If I gave you 1 over a plus 1 over b, what's the LCD here? AB. So can someone tell me what the least common denominator is for b? For this one right here? R times what? R minus 3. You multiply to get the least common denominator. In this case, the least common denominator is r times r minus 3. Therefore, what do you multiply by this? What do you multiply this fraction by? R over R. You have to say the whole sentence, okay? You just saying R is the equivalent of me going, what's your favorite color? And you going, my favorite color. Like, I need the other half, okay? I need the other half. What about this one right here? What do I multiply this one by? Yeah. Whatever you multiply has to be the same on the top and bottom. So what do you end up with? 6 times r minus 3 over r times r minus 3 minus 5 times r over r times r minus 3. What do I now have? What do I now have in both of these fractions? This is, you have this and you have this. Therefore, you have a common denominator. We didn't have to factor because there wasn't anything to factor, but now we built a common denominator. Now that we have a common denominator, what can we do? We can subtract. So what is this going to be? 6 times r minus 3 minus 5r all over what? Now that doesn't, it could be simplified a little more. We're not going to do that quite yet. And you might ask yourself, why do this if doesn't look any nicer. Sometimes the only way to move forward on a problem is to combine fractions. Sometimes you have to combine fractions. Can we simplify this a little bit? Yeah, what's this going to become? 6r minus 18 minus 5r all over what? R times r minus 3. Here's a really important time for me to tell you something that's really important. Do not multiply out unless you must. Do you understand? Do you see how I didn't multiply the denominator? Do not multiply out unless you must. So can we simplify that a little more?
Yeah.
So it's going to be r minus 18 all over r times r minus 3. This would be the answer I would look for right there. Stop there. Yes, Mark?
Couldn't you just have crossed out r minus 3?
No, you cannot because of the minus sign. No, you cannot because of the minus sign. Please, please, please do not do that. Please, please, I beg you. Please, please, do not. Very sad. Okay, so let's try another one. Do we have a common denominator on this one right here? It's close, right? Like you want it to be the same, but is it the same?
Oh, no, we just multiply by -1.
No, you can't. Because it's not the same. If it was 1 minus q, you could. See how it's q? If it was q minus 1 and 1 minus q, then you could multiply by -1 over -1. You can't in this case. They're not the opposites. You want them to be because I mentioned it before, but they're not. They're close to. Some of the weirdest errors happen when you see something that's like super close to what you want it to be. And then sometimes in math, guess what you get to do? Yeah, they're the same. I'm not kidding. Sometimes you get to say that, and it's legal. But you have to take more math and have to justify it, and it gets really weird. Opinions matter all of a sudden in math. Okay, can someone tell me what the least common denominator is on this one? It's right there. What is it? Q minus 1 times? Yeah, exactly. You can always, listen, you can always get a common denominator by multiplying all the denominators together. Is that necessarily going to be the least common denominator? No, like up here, what was the first fraction we dealt with? The first one we did was 5/12 plus 7 over 15. What was our least common denominator? 60. Could you just multiply 12 and 15? Is that bigger than 60?
A lot.
It's significantly bigger. So you can, it's much bigger, right, exactly. It's much bigger. But if you're stuck, can you always just find the common denominator and simplify? Sure, if you get stuck. Least common denominator is nice though. So let's go back to this one. So what do we multiply this one by right here? Q minus 1 over Q minus 1, correct. What do you multiply this one by? Exactly. So what do we end up with? Q plus 1 over Q minus 1 times Q plus 1 minus Q minus 1 all over. What do we now have? We have a common denominator. So now what can we do? We can actually do the subtraction. So what do we end up with? And that's a really terrible Q I just wrote right there. What do we end up with? Q plus 1 minus Q minus 1 all over Q minus 1 times Q plus 1. Can we simplify this? Yeah, it turns out to be Q plus 1 minus Q plus 1 all over that same thing. Do I multiply out the denominator? No. Do not multiply it out unless you have to. And there's no reason to multiply it out right now. What cancels in the numerator right now? What can you cancel out? The Q's. So what do you end up with? 2. So 2 over Q minus 1 times Q plus 1. Nice. That is fully simplified, fully factored. That's a great clean answer right there. That's great.
Why did you cancel out the Q?
Because it's Q and minus Q. Q minus Q is 0. They're gone. And 1 plus 1 is 2. Nice.
Isn't it 1 minus 1?
No, it's not. Yeah. Y minus 2 times 2 minus y. So what do we multiply this one by right here?
1 minus 2.
No, keep going.
Over 1 minus 2.
You have to say the whole thing.
Oh, yeah, that's right.
You have to say the whole sentence. So what do you multiply this one by right here? The other one. Yeah. So if you do that, you end up with y times 2 minus y plus 8 times y minus 2. And what's the common denominator now? I'm doing 2 steps. Yeah, I'm doing 2 steps here. 2 minus y, sorry. So can we simplify the top? What do you think?
Yeah.
I think we can simplify the top. So what do you end up with if we multiply out the top, Summer? Can you tell me what you get if you multiply out the top? What do you end up with?
We end up with y
2y. Yep.
Yeah, 2y minus y squared.
Yep.
Plus 8y minus 16.
And we don't multiply out the bottom because we're not done. Can we simplify the top a little bit?
Yes.
Absolutely. So you end up with what? Negative y squared. How many y's do we have? 10y minus 16. Now what can we do? Factor. We don't like that negative sign in front of y squared, right? I don't like it. So what can you factor out of the top? Negative 1 times y squared minus 10y plus 16. I just like getting rid of that negative sign so we can ignore it. Now we need to factor this thing right here. Can someone factor that for me?
Is it x minus 8x?
Not x, it's what?
Or y minus 8?
Yep.
Y minus 2.
Correct. Y minus 8 times y minus 2 all over this. Oh, look, does something cancel?
Y minus 2.
Look at this. That cancels, so what are you left with? Negative 1 times y minus 8 all over. So I would write it like this. Negative y plus 8 over 2 minus y. And then I would further write it as 8 minus y over. Done. That would be the fully factored form right there. That would be the fully factored form. Yes, Mark?
From the beginning, like before we can go all the way back.
Yep, I sure can. Yep.
Unsimplified version.
Yep.
Is it on the bottom? Shouldn't it be y minus 2 times 2 minus y?
That is what's there. Right there. Right here. Here it is. There's your denominator. Y minus 2 times 2 minus y. So here's the thing. We did.
Before.
What? No, there shouldn't. Nope. The least common denominator is right there. There it is. The least common denominator is y minus 2 times 2 minus y. So we made it. There it is. There's only that is the least common denominator. Sorry. Yep.
Shouldn't you include the y minus 2 times 2 minus y?
It is. It's right there. There it is. Okay. Do you understand? I skipped one step that might have messed you up a little bit. So we did this multiplication. So what did we end up with? Y times 2 minus y over y minus 2 times 2 minus y plus 8 times y minus 2 over 2 minus y times y minus 2.
Yeah,
We now have a common, so now you see this? What do you have right there? Common denominator, and that's how we got to there.
I get the top, but what happened to the bottom?
It is the same. This is the same as this is the same as this. Those are the three exact same things. They're the same. So if you have a common denominator, what can you do with the fractions?
You can switch the order.
You can switch the order. It doesn't matter what order they're in. A times B is the same as B times A. Those three things are the same.
No, I'm
Same.
just asking how you went to
How I went to what, Mar? Ask the question.
writing it twice.
What does the first one factor into? 5 over what? X plus 5. And what's the next one factor into? X plus 5. Good. So Zoya, can you tell me what the least common denominator is?
X plus 5 times x plus 5.
Yep.
Times x plus 2.
Excellent. So what do you multiply this fraction by, Zoya? What's missing?
X plus 5.
Over. Yep, gotta say the whole thing. And what about this one, Connor? What do you multiply that by?
X plus 2.
Yeah. So now you just do the multiplication. You have 5 times x plus 2 over x plus 2 times x plus 5 squared plus 2 times x plus 5 over what? The same thing. What do we now have? What do we now have? Common denominator. So what can we do with the fractions now? If you have a common denominator, what can you do with the fractions? Add them. So end up with 5 times x plus 2 plus 2 times x plus 5 all over x plus 2 times x plus 5 squared. Can we simplify the top a little bit? Yeah. 5x plus 10 plus 2x plus 10 all over the same denominator. So what does it equal? How many x's on top? 7x plus over x plus 2 times x plus 5 squared. And you would be done. There it would be. Yes, Mar?